Second is that we have to choose one of the importance scores as a reference. Or we don't have to, but it's just easier to do that, to choose one of them as a reference. And the one that we want to choose as a reference is going to be the one that we can then go ahead and plug into this equation. So we can say, suppose we got everything in y, then we have some function of y, some function of y, and some function of y equals 1. Then we can plug that in and then solve for y, right? And then everything else would fall out of it. So let's first look at these equations, these three equations right here, and see which of the variables would be the easiest to work with as our reference. So let's choose z as our reference here because we can pretty easily get everything in terms of z, right? We already have w in terms of z, then we can get x in terms of z because we'll have w in terms of z, and then we can also get y in terms of z using this last equation. So that'll be probably the least tedious path. Now, again, you could choose any one of them and it won't matter. It's just we're trying to make the math as simple as possible here because we don't want to deal with heavy math. So we'll choose our reference value to be z. So to start off, then we'll go w, x, and then y and try to get them all in terms of z. So for w, we'll just use the first equation. We already know that w is equal to z over 3. So that's easy because then when we plug in here, we just have w equals z over 3. So we're done with that for now. Now let's move on to x. Now we want to get x in terms of z. So we have x equals w over 2 plus z over 3. So now, we already have w in terms of z, though. We know that w is equal to z over 3. So we can say that x is equal to w over 2 plus z over 3, which is equal to, then on this side, this w term over here is z over 3 divided by 2, because this is just equal to z over 3, plus z over 3 again. So that's z over 6 plus z over 3. And then if we can, for instance, make each of them a common denominator, so we have z over 6 plus 2z over 6, which is then 3z over 6, which is equal to z over 2, 1/2 z. So now we have w is equal to z over 3, and x is equal to z over 2. So you can already tell now that since z is between 0 and 1, that x is going to have a higher importance score than w, because w is just 1/3 of z, whereas x is only 1/2 of z. Now we can move on to y. So rather than using, again, this equation where we'd have to plug in everything for w and then x, why don't we just work with this equation down here, because we already have, and we can say that y is equal to z minus x over 2. So we'll say y is equal to z minus x over 2, right? Because we already have y on this side, so we can just subtract x over 2 from both sides. And then we had x as before is z over 2. So this is z minus z over 2 over 2, which is z minus z over 4, which is just 3z over 4, 3/4 z. So now we have that y is equal to 3z over 4. So notice a few things. First of all is that we chose each of these three equations up here to get w, x, and y in terms of the reference variable z. And now we have those three relationships that we need in order to plug back into this equation. Then we can solve for z using one equation and one unknown, which is the basis for everything here. And also notice that we chose the simplest equation to work with first, right? Simply that w is equal to z over 3. We didn't have to do any substitution or anything in that equation. And then we moved on to the more complicated equations, and everything kind of fell out, and we used what we had before to solve for what we needed to do at the present. So that's the way to go about this, is that you sort of unlock different pieces of the puzzle, so to speak, as you go on, and then you use what you've unlocked in terms of what variables you've already gotten in terms of z to keep moving forward in the process.